So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic rate of chemical reaction. So guys, in short, stay till the end of this video as this video is very important. So we are going to start with the first question here. We have a diagram and the question says, in the diagram above, the curve that represents the production of oxygen gas from the decomposition of potassium trioxochlorate 5 in the presence of manganese 4 oxide catalyst is A, Q, B, P, C, R, D, S. So guys, the curve that represents the production of oxygen from the decomposition of potassium trioxochlorate 5 is the P here, and that's option B. So let's go ahead and check out the next question. Question number 2. It says the reaction between 5 grams of iron fillings and 0.5 moles per dm cube can be made to proceed faster by A, adding some concentrated tetroxosulfate 6, B, adding 0.5 moles per dm cube of sodium hydroxide, C, using 0.25 moles per dm cube of acid instead, and D, cooling the reaction vessel. So guys, the answer to this question will be option A here. The rate of chemical reaction is directly proportional to the concentration. So the addition of some concentration will increase the rate of the chemical reaction. So that's it for that. And when we add a concentrated tetroxosulfate 6 solution to this reaction, it will actually increase and make the reaction to proceed faster. So that's the answer to that question, option A. So let's consider the next question, guys. Question number 3. It says, all right, here we'll also have a diagram here. So the question says the graph above demonstrates the effects of A, concentration on the rate of reaction, B, surface area on the rate of reaction, C, catalyst on the rate of reaction, D, pressure on the rate of reaction. So guys, we see here the mass of carbon dioxide produced and then the time taken. So we see the curve here showing the end point of the first reaction and the end point of the second reaction. So the first reaction is that of marble powder, that's powdered marble, and then the second one is that of marble chips. So you notice that the powdered marble has a higher chemical kinetics since it has a larger surface area compared to that of the marble chip. So guys, this illustration is actually showing the effect of surface area on the rate of reaction. So that's it for that, and that's option B. So let's consider the next question. Question number 4. It says these are factors affecting chemical reaction except A, catalyst, B, energy, C, nature of reactants, D, surface area. So guys, the answer to this question is option B, and that's energy. So let's consider the next question. Question number 5. It says activation energy is defined as A, the energy needed to break chemical bonds in reactions, B, the energy released during chemical reactions, C, the energy gained by products after a chemical reaction, D, the energy difference between reactants and products. So guys, the answer to this question is option A, and that's the energy needed to break chemical bonds in reactants. So let's consider the next question. Question number 6. It says the graph that describes a zero order reaction is, all right, we have options A to D here, the graphs here. So guys, the one that describes the zero order reaction is the graph in option D. So that's the answer to this question. Let's consider the next question. Question number 7. It says which of the following factors will speed up the rate of evolution of carbon dioxide in the reaction below? So we've seen the equation of the reaction here. So option A says reducing the surface area of calcium carbonate, B, increasing both reactant and products, C, reducing the concentration of the acid, D, increasing the surface area of calcium carbonate. So guys, the answer to this question will be option D here, and that's increasing the surface area of calcium carbonate. So the chemical reaction can be increased by increasing the surface area of the reactants. So increasing the surface area of the calcium carbonate will speed up the rate of evolution of carbon dioxide. So that's it for that question. Let's consider the next question, question number 8. It says, so we have a diagram here as well, and the question says, from the reaction above, which of the following curves represents the production of carbon dioxide gas as dilute HCl is added? So guys, we have options A, N, B, L, C, M, and D, P. So guys, the answer to this question will be option A, and that's N. That's the curve in this graph that represents the production of carbon dioxide gas as dilute HCl is added. So guys, the next question here, question number 9, says, in the equation above, the rate of formation of Z is found to be independent of the concentration of Y and to quadruple when the concentration of X is doubled. The correct equation for the reaction is A, R is equal to K times concentration of X to the power of 0 times concentration of Y to the power of 2. And then B, R is equal to K times concentration of X times concentration of Y. C is equal to K times concentration of X to the power of 2 times concentration of Y. And then D, R is equal to K times concentration of X to the power of 2 times concentration of Y to the power of 0. So guys, the rate of formation of Z according to the equation is independent of the concentration of Y and quadruples when the concentration of X is doubled. So this implies that the reaction is first order with respect to S and zero order with respect to Y. Hence, the equation is going to be that represented in option D. So that's it for that question. So let's consider the next question, question number 10 here. All right, so we have a table here, and the question says the results obtained in a kinetic study of the reaction A plus B to yield E plus F at 25 degrees Celsius are given in the table below. So we've seen the table here, and it says here, what is the rate law for this reaction? So guys, here we are going to simply zoom into our workspace and try to solve this together. So the first thing we are going to do is, well, first of all, we're going to write the equation for the rate law. We are going to have our rate to be equal to K times concentration of A to the power of X, then times concentration of B to the power of Y. So guys, having written this way, we are going to first of all solve from equation 1 and 2. So if we take the ratio of equation 2 to that of 1, you're going to have R2 over R1 to be K times, now concentration of, all right, so concentration of A with respect to the R2 will be 20, sorry, will be 0.20, and then concentration of, so this will be raised to the power of X, don't forget this. So for concentration of B with respect to this, the second rate, it's going to be 0.40. So we're going to put it down 0.40. So it's the power of Y. So this is it. So for R1, we're going to say for the rate 1, that will be k times concentration of A with respect to the first rate is still 0.20 actually. So this is raised to the power of x, and then for concentration of B with respect to the first rate is also 0.20. So we're going to put that here, 0.20, and raise this to y. So this will be equal to the quotient of their rates as well. Rate 2 is 8.0, or just 8 anyway, times 10 to the power of negative 5. So whereas rate 1 is 2.0, or just 2, times 10 to the power of negative 5. So guys, having written this out, k is out here, and then 0.20 to the power of x is out, then so if we take 0.40 to the power of y and divide it by 0.20 to the power of y, we're going to have, let's calculate 0.40 divided by 0.2, and that's 2 guys. So for this quotient, we're going to have 2 to the power of y. So we're going to say this is equal to this. So when we divide 8 by 2, we are going to have 4. So 10 to the power of negative 5 will cancel out. So 8 over 2 will be 4. So in order for us to find what y is, we are going to make the bases the same. So we're going to say 2 to the power of y is equal to, so 4, if we want to convert 4 to 2 to the power of something, that's going to be 2 to the power of 2 again. So 2 to the power of 2 is still 4. So it means that if we slash out the bases, we'll have y to be 2. So y is actually 2 here. So now that we've gotten y, we're still going to solve for x by using equation 1 and 3. So let's go ahead and wipe this off first. So we're going to use equation 1 and equation 3. So let's say equation 3 divided by equation 1, or arrow 3 divided by arrow 1. So we're going to write this here, arrow 3 over arrow 1. So for this, we already know that. Okay, let's write down our equation here. So rate is always going to be k times concentration of A to the power of x, then times concentration of B to the power of y. So it means that for this, we're going to find, first of all, the concentration of A with respect to the third reaction. So concentration of 8 with respect to the third reaction is 4. Concentration of 8 with respect to the third reaction is 0.4. So this is to the power of x. And then for B, it's 0.2. So this will be to the power of y. And this is over, for R1, it's 0.2 here to the power of x, and it's still 0.2 here to the power of y. So we are going to equate it to their rates. So the rate for the third is 4, or 4.0 times 10 to the power of negative 5. And then for 1, we have 2 times 10 to the power of negative 5. So with this, we can cancel out y, and we can cancel out this, every other thing. So remember that this is times k, so we can cancel out the k, like from this equation here. So with this, we can simply say 0.4 to the power of x over 0.2 to the power of x. So 0.4 over 0.2, that's 2 to the power of x. So 2 to the power of x will be, so this here we can just simply cancel out 10 to the power of 5, or 10 to the power of negative 5. So 4 over 2 is 2. So it means that this is 2 to the power of x is equal to 2 to the power of 1. So in that case, x is equal to 1. So with this, we can have this stated as our rate is equal to k times a to the power of, since our x is 1 here, 1, and then times b to the power of, we got our y to be 2, so this is going to be 2 here. So that's it for this question, and the answer to this question will be option A, and that's the correct answer to this question. So let's go ahead and wipe this, and this is where we'll end this video, guys, for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. If you have any specific question regarding this video, guys, you can drop your question on the comment section below, and we'll ensure to give you a response. So guys, we also want to encourage you to join our YouTube channel community by hitting the join button below. So thank you once again for watching this video, and see you on the next one.